Hello and welcome to this presentation about client-side 3D analysis. My name is Miriam Chonen and I'm here with my colleague Hugo Campos. We're both developers on the ArcGIS API for JavaScript team, and we mainly focus on 3D features. Today we'd like to talk to you about the tools that the API provides for analyzing digital content in 3D scenes. First, Hugo is going to give you an overview of the analysis widgets that we offer and how to use them. This includes the area and line measurement tools, the slice plane, line of sight analysis, and elevation profiles. Then, we're going to do a deep dive into querying and filtering, where I'm going to describe how to filter and query by attributes and geometry.
Let's get started with the analysis widgets. The ArcGIS JS API provides a series of widgets which can be added to a view in order to perform client-side analysis, and which you can customize or enhance. Before we dig deeper into each of the analysis widgets we're going to cover today, let's take a quick look at the structure of the API widgets. We have the widget itself, which handles the rendering of the UI and listens for input from the user. This can be clicks on buttons or checkboxes being toggled or other things like that. Then we have the view model. The view model encapsulates the state and business logic of the widget. It knows how to interact with the rest of the API, and it provides access to all the information that the widget needs to render the UI. It is not associated with any UI framework and doesn't know at all how the information is displayed in the UI. One could take a view model and build a custom widget on top of it, using React or Vue.js or whatever other framework you may be using. One could also take a view model and add functionality to a scene view or map view without displaying any UI at all. You can visit our API docs page to learn more about view models, about why we use them. There are lots of samples, lots of examples that you can look at. So now, with this in mind, let's look at how we can use some of the widgets and their view models to perform some client-side 3D analysis. The first widget we will look at is the DirectLine Measurement3D. We start by creating an instance of the widget. We give it a view where it will operate. We then add the widget to the view's UI. This will make the widget show up in the view. So let's try to run this and see what happens. Now I have my widget and I can create a new measurement. I can click and then move my mouse pointer and I can measure vertically or horizontally, but I can also measure diagonally. And if I do this across long distances, I can also measure geodesically. I can also change units. We could pick, for example, imperial units, which I've heard are very popular in the US. However, I'm in Europe right now, so let's suppose I only want to allow my users to select meters or kilometers. What I can do is access my widgets view model and specify that the default unit is kilometers and that the unit options are going to be meters or kilometers. If I do that, I can see that my widgets units switch to kilometers and that I can only select meters or kilometers. Now let's look at something a little bit more interesting, the slice widget. Just like before, we create the widget and we give it a view. We also add it to the view's UI. So let's try it out. The slice widget lets you place a plane in 3D and it will slice the view based on that plane. So let's place a plane here. We can see now that my building is cut. We are slicing the view according to this plane. I can now shift this plane around, or I can also rotate it. If I want a bigger area, I can scale the plane. I can create a new slice and place it somewhere else. And I could exclude a layer. That means just excluding the layer from what is being sliced. So if I click, for example, on the walls will not be sliced. This way, if I move my plane here, I can see inside of the building, but the walls don't get sliced. I can also exclude the roof. And now the roof is not sliced. So let's get back to what we had initially. Now, let's say that I want to programmatically specify my slicing plane. What I can do is I can create an instance of a slice plane. It has a spatial reference, it has a position, it also has a heading, and it has a tilt and a width and a height. This tells our widget all it needs to know to be able to slice the view just like we do here. Then, once we have set that on the shape property of the view model, we can tell the view model to start slicing. So essentially, we apply the slice plane to the view when we call start. So let's do that. There we go. We've applied our slice plane here to the building. Let's take this a little bit further, and let's build an application which allows us to select from a predefined set of slice planes and viewpoints. In this case, I want to be able to see the building from the top or from the front. So when I click on a button, I want to be able to see the building from the front, and when I click on another button, I want to see the building from the top. So the first thing I need to do is to create a scene in the scene viewer containing a slide for each viewpoint that I want to have. So I'm going to have a slide looking at the building from the front, and I'm going to have a slide looking at the building from the top, more or less like that. I then have in my code a list of my slides with their titles. I also have a slice plane that I want to apply for each of the slides. So I have a slice that I want to apply when I'm looking at the building from the front, and I have another slice plane that I want to apply when I'm looking at the building from the top. Now I can create my buttons. For each of the slides that I have here, I'm going to create a button. I will find the slide in my scene by the title. I will then create the button, add the button to the view on the bottom left, and then whenever the button gets clicked, I will set the shape. So I will set my slice plane on the view model, and I will start the view model. So I will apply the plane. This is just like we did before. Finally, I will apply my slide to the view. This will move the camera to the correct viewpoint, either to the front or to the top. Let's try that and see what we get. Here we go. We have two buttons, one to look at the building from the front and one to look at it from the top. If we click here, there we go. We look at the front of the building and we have our slice plane. Can still manipulate it just like before. And now if we click on the top button, we look at the building from the top. Again, we have our slice plane. We can rotate it, we can scale it, just like before. And all of this programmatically. Another thing that we sometimes want to do is determine whether a certain point, let's say here the square near the church, whether a point here can see another point, or whether a point is visible from that point we're interested in. That's where the line of sight comes into play. As before, we just create the widget and we add it to the view, and we get our widget. So like I was saying before, we can click somewhere and then we place our observer. Now we can go ahead and place targets. So I can check here the church tower, or I can check this building here, or this roof here, or maybe these buildings over here. Now I can see that from this point, I can see the church tower, but I cannot see these buildings over here. They are being obstructed by something else. So let's build a small application here, which allows us to click anywhere in the view. And based on where we clicked, we want to see if the church tower is visible. So I click somewhere, and then I will be able to tell whether the church tower is visible. So let's do that. The way we do that is by first having a list of targets. So these are just some points that I've placed around the church tower or on the church tower. Then I set a view handler here, a handler for clicks. Whenever the user clicks, I'm going to perform a hit test. This is going to tell me what was clicked. So when I clicked here, it will tell me which point was clicked. So when I get here, the first thing I want to do now is start my new analysis, my new line of sight analysis. I set my observer to the point that I was clicked. This came from the hit test up here. Then I set my targets, just the targets I had here. Remember, the points on the church tower. Finally, there's this little bit of code here, and all it does is it switches the view model to the stop mode whenever it starts creating. What this does is essentially that we start a new analysis here. We then set the observer and the targets, but we are still in the creating state. That means people could go and click on other points to add more targets. We don't want that. So when we go into the creating mode, we immediately switch back to stop. So that way, we set our observer and our targets, and then we don't let people place any further targets. So let's try this. We've run the code, and now if I click here, I can see that my church tower is clearly visible from there. Let's see from the river. Unfortunately, from this area here, we cannot see the church tower, but from here, we can see the top of the church tower. So we could take this further and just customize this. We could add other landmarks. We could check whether the mountains are visible. There are many things we could do with this. The final widget we will look at today is the elevation profile widget. This one is typically a bit more complex to set up. We need to provide it the view, just like before. But then we also want to specify which profile lines we want the widget to generate and display. Here, we're telling the elevation profile to generate a profile for the ground. So we will get one line which will sample the ground elevation or your terrain here. I'm also giving it a color and a title. This will display in the widget. Finally, like before, we add the widget to the view and it will show up over here. So let's do that. And there we go. We have our widget. I can now click on New Profile, and I can draw some lines here to create profiles. So if I create a line here, I will get a profile of this hill. I can see that I have my elevation plotted here in the widget. As I hover, I get the elevation at that point, and that same point is also shown in the view in 3D. I also have some statistics about the elevation profile. I have the length, the minimum elevation, maximum elevation, and so on. If I want, I can switch units just like we were able to do with the DirectLine Measurement3D. Finally, I can also click here on Generate from Path. And what this does is, if I have any polyline anywhere in my scene, I can click on it and generate a profile from it. Just like we can draw, we can also select something. Now let's make this a little bit more interesting. Let's go over here to the river. Here on the side of the river, we have some terrain, but we also have some buildings. So it would be interesting to see the difference between the two. So to see the buildings and to see the terrain or the ground. So what I can do is I can add a new profile line. In this case, it's of type view. I give it a name, layers. So it's going to be my buildings. Give it a different color. And what I do here is I tell it to exclude the ground because I already have a ground line. So in this case, it's going to be only the buildings, and this one is going to be only the ground. So if I do that, you can see that now I have two profile lines here. So let's generate a profile here by the river. When I do that, I can get like that. And maybe let's adjust this a little bit to see it better. And there we go. We have a profile where I can see the ground below and I can see the buildings above. I can also see the preview over here. You can see the lines just like in the 2D chart. You can see them also in 3D. And again, as before, when you hover, you see the elevations here in a tooltip, and you see the points in the view moving as you move the mouse over here. So let's look at how we can export the data generated by the elevation profile widget. In this example, we will export the data as a CSV file. The idea here is that I can create Generate from Path, select a path, and then I get a profile here. So we want to have a button that when we click it, exports the data as a CSV file. So let's look at how we can do that. Here at the top, we create the button and we add it to the UI. Then, when the button is clicked, the first thing we do is we grab the first profile line in our widget. That's going to be here, the ground, because we only have one line. Then we make sure that the profile has been fully generated. Otherwise, we don't want to export it because we don't want to have temporary data or intermediate data. So here, we take those samples from the ground profile line and we pass it to this open source library called JSON2CSV. And we tell it to include the distance, the elevation, the X, Y, and Z fields. Our CSV file will include these fields. Finally, we take the file we've created and we allow people to download it using filesaver.js. So now, when I run this, I get a button here. And when I click it, I get a CSV file. And the CSV file is going to include a distance, elevation, X, Y, Z. And now I can use this file and import it into some other tool or perform some analysis on the profile. There's other things you could do. You could also export statistics. There's a statistics property in each of the profile lines. So you can get any of the information that the widget has to display over here. You can grab that information and you can export it, or you can use it to create custom visualizations, or to even customize how this looks. You could put, for example, you could put some markers along the way. There are many things you could do here. As we've seen, there are many possibilities to customize and enhance widgets in the ArcGIS API. And now I will pass it along to Miriam, who will talk to you about querying and filtering scene layers.
Thanks, Hugo. So in this second part, we're going to be looking at a few ways that we can analyze the attribute data in a 3D object scene layer, and how we can do this directly in the web client. So first, we're going to load the web scene from its portal ID. This is a scene that I've created in a scene viewer. It contains a 3D object scene layer with buildings from Helsinki. The features in this scene layer are all individual buildings, and they are equipped with attributes such as the building's height or the year that it was constructed. As a first step, we wait for the web scene to load, and then we retrieve the layer by its name. We then wait for the layer to fully resolve, and then we can retrieve the layer view. The layer view is required later for the client-side querying and filtering. Once the scene loads, we can click on one of the buildings, and we will get this pre-made pop-up. This shows all the attributes that are available for this feature. However, it is not very human readable. So the first thing that we can do is to override this pop-up template in the layer. We're replacing it with a very simple sentence and putting the address in the title field. You'll notice that the curly brackets contain attribute names, which are then replaced with the actual values. We can be a bit more fancy here though. The content field actually accepts an array of definitions, which are then stacked on top of each other. So we can have this text that we initially set, but also add this table underneath, which is just defined by an array of field infos. This looks very similar to the default pop-up that we had before, but now we have control over the labels and the values. Before we dive into the specifics of querying and filtering, we should discuss the differences between the two. They are similar in that they operate on the attribute data of features. However, filters are used to remove features from the view based on certain conditions. On the other hand, queries do not directly affect the view. They can be used to extract the attribute data from the features in various ways. Let's get started with a really simple filter. So that you can better see what I'm doing, I'm going to replace the realistic textures with this class breaks renderer. What this does is it simply takes the construction year of the buildings and assigns it a color based on that. Now we can set the filter on the layer view.filter. It's important to note that any attribute that you're using in your filters should be added to this layer.outFields property. This will ensure that the attribute is properly loaded from the server. Otherwise, it might be missing and you will not get the correct results. If we run this now, you can see that the filter removes anything that does not satisfy the statement that we put in this where field. This is a simple SQL statement, and you can put pretty much anything there. For now, I just configured it to remove any building that is older than 1950. If we want to remove the filter, we can simply set it to null. You can visit the ArcGIS online documentation for more information about this class. It has a lot of useful infos and code samples to get you started. Be sure to also check out the filter section on the Scene Layer View documentation. Next, let's try driving this filter by something a little more interactive, rather than hard-coding the condition. With this code here, I am adding a time slider. This is another one of the widgets that the API provides, similar to the ones my colleague described before. You will notice that when I move the slider now, nothing actually happens. This is because we need to hook up the time slider to the filter first. We do this by setting a watch on the time extent property and then running the filter. Now when I move the slider, we can see the buildings disappearing by age. One thing to note is that this slider is set to not just display this one point in time, it is configured to cumulative from start. This means that it will display all the buildings from 1900 up until now. This mode can be changed to only show a slice in time, or do the reverse and show from a certain point to present. For more information about the time slider, be sure to check out the API docs on this class. Now it's time to look at querying the attributes for data that might be of interest to us. We're going to be working on an attribute that is called Solar Area Suitable M2. This means the square meter of solar panels that could potentially be built on any of these buildings' roofs. In this sample, I have already replaced the realistic texture with a visual variable that is driven by exactly this property. Once again, it's important to add all the fields that we're going to be using to the layer.out fields. You'll see in a minute why I've added the address here. You can create a query by calling the layer view. Once you have the query, it has a where field that is very similar to what we've just seen on the filters. This is again just a very simple SQL statement that I've used here that will return true if the building can support a solar panel between 400 and 500 square meters. What's new for queries is that it has this out field property. Here we are going to specify what we would like to receive in return. Once we run this query on the layer view, it will return a list of all features that satisfy the where condition. And for each of these features, it will give us exactly the properties that we've requested here. So currently, just the address. And when I run this, you can see in this custom HTML element that I've added the list of addresses that are returned. One thing to note is that all of this is client-side, which means that it is rather fast because it doesn't need to do a round trip to the server, but it also means that it is view-dependent. So if I zoom in here and rerun this query, you will notice that we will get less results. This is because less features are within view and thus loaded for the query. There is a second function on the layer view for querying. It's called query object IDs. What this does is it doesn't return any attribute values, it just returns the object IDs of all features who have satisfied the where condition. This is useful if we just want to visualize them, for example, with the built-in highlight function on the layer view. If you want to remove the selection, simply call remove on the handle that was returned by the highlight function. This next sample is almost entirely identical to the one before. I have simply replaced the address field with the usage attribute. This contains zoning information of the buildings. So, for example, whether they have residential or commercial use. I am showing this because I want to illustrate an additional setting that we can set on the query. You can see in this list of the query result that we get a lot of identical results, and this is not very useful. But we can set this query.return distinct values to true, and then we will only get the list of all distinct values that are returned by the query. This brings us to statistical analysis. We may want to know how many buildings are in each of the zoning categories that we've just seen, or it might interest us what the distribution is of the solar potential in the city. You can certainly do this manually by exporting the data that is returned by the attribute queries to an external tool. However, there are already quite a few handy tools for this on the query object. You can access them via the query.outStatistics field. This takes a list of statistic definitions. Each of these aggregates data in a certain way. The first field is just an identifier. We will use this to access it later. The onStatistics field determines what kind of data is aggregated. Here, it is just the name of an attribute. However, this can be any SQL statement. You can aggregate the sum over several attributes, etc. The statistic type defines how it is aggregated. Here, we are simply taking the average of the values, but it also supports minima, maxima, sums, standard deviations, and similar functions. The statistical analysis is run through the same function that we've used for the attribute queries before. It's important to note that this will now not return a list of features. It will only return a single feature, and this feature will have one attribute for every statistic definition that we've passed in before. If we want to do something a bit more sophisticated, like a bar chart, we will need to define one statistic definition for every bin in the chart. So what this does here is we've set a condition on the statistic field that will evaluate to true exactly if the building is inside the bin and to 0 otherwise. We then sum over all of these occurrences, and this will give us the total number of buildings inside each bin. I have then passed this to a chart that I've created with charts.js, but you can use any utility that you like, really. I have also additionally set this global query.where just to show you that this also still works in combination with the statistics. So the data we see over here is only on the buildings that have an industrial zoning and not any of the others. The last thing I'd like to show you is spatial filters and queries. To demo this, I have added the sketch widget to the top right of my app. This is another one of the built-in widgets that the API offers, and you may have already seen how to use it in the editing session by my colleagues Ravi and Roman. If not, I can highly recommend their session. The sketch widget allows me to draw points, polylines, or polygons interactively in the scene. This bit of code instantiates the sketch widget, assigns it a graphics layer which it requires to function, and then sets 2 watches, one on the creation and one on updating the shape. What this means is, as soon as I create this, and whenever I move it, the geometry of the shape will get passed into the geometry field on the filter. And what this does is it will filter out any features that are not inside the shape. This will also work in a very similar fashion for queries. The query object also has this geometry field to which we can simply pass the geometry of the shape. The query will then only return features that are inside the shape. We can further refine the behavior for both filters and queries with a number of additional settings. The spatial relationship is currently set to contains, This is why the filter returns values that are inside the shape and none outside. This can be set to do the exact reverse. I will show more examples of this momentarily. The next setting of note is the distance. If we activate this query and again apply the highlighting that we've seen before, you will notice that it returns features that are slightly outside the shape. This is because I've set this distance to 100 meters. This acts as a constant width buffer region around the shape, which is also accepted as valid results. Query.units is simply the unit of this buffer region. Finally, I've also set a query.where again, so you can see that we only return buildings that have the residential zoning. This is again just to show you that all of these different settings work together. Note that while I've used a polygon to explain this, it also works with points and polylines. You do not need to use the sketch to add the shape, you can also add it programmatically, or extract it from a feature layer. One thing that I would strongly recommend is to debounce the query with this promiseutils.debounce function. What this does is it tracks all the running queries for you and ensures that there is never more than one running at the same time. As a consequence of this, I can move the shape around very fluidly, even though the query takes a very long time to complete by comparison. Without this debounce step, this app would be much less responsive. So for the spatial relationships, the scene layer supports 3 different types. The first one is intersects. This will return all features that have any part of them inside the shape. In comparison, contains will only return those features that are entirely inside the shape, not the ones that are clipped by it. And lastly, disjoint is the exact opposite. It will only return features that are entirely outside of the shape. For further information, I strongly suggest that you check out the query section on the API doc page. It has a lot of additional information, especially about these different query types, the attributes, spatial or statistic queries, and how they interact. In addition to this doc pages, I can recommend that you check out the sample code section. There are a lot of great tutorials for all kinds of topics here. For example, there is one about querying statistics by geometry. Furthermore, my colleagues Russell Roberts and Raluca Nicola published a blog post that goes into great detail about how to publish a web app that explores a 3D object symbol layer in a step-by-step and very detailed manner. I can highly recommend that you check it out if this topic is of interest to you. That is all we had to share with you today. Thank you very much for attending, and we hope very much that you enjoyed your time. Please don't forget to provide feedback with the survey link directly below. We always hope to improve, and your feedback is crucial. We're looking forward to answering any questions that you might have about the session.
All right. So I hope you guys like the presentation. We're going to try to answer some questions. I see that we have already some of them. So both me and Miriam are live here. Should we go ahead, Miriam? So let's start with there's this one here from an anonymous person. Will there be a volume calculator tool? You want to answer that, Miriam?
Yes. So currently we don't have it on the roadmap, but it's definitely something that we can look into for future releases.
All right. By the way, if you still have some questions that you'd like answered, feel free to post them. We still have some time to look at them. So we also have a question here. I need to calculate the length of a 3D line, but the distance measurement tool only allows me to measure the distance between 2 points. Help. So this comes from Carlos. So there are several things you could do. One is you could use the geometry engine. We can share a link. We can reply to you with a link for that. So that's one way. You could use the elevation profile, also allows you to compute the distance. And we are also working on some new tools for this, which are going to be coming out in the next release probably. But you should check out Javi's presentation from earlier today. Talks a little bit about some of the things that will be coming out. But yeah, if you just are just interested in the measurements, take a look at the geometry engine. So what else? Is there a Git for Viewshed demo in the presentation? So we don't have any Viewshed in the presentation or in the API at the moment. We have the line of sight. The Viewshed would just be sort of like an extrapolation of the line of sight, right? But yeah, it's not in the immediate plans to have Viewshed, but we're going to consider it for the future. What else?
The code for all the demos that we've shown in the presentation, you can find it. There's a link on the main page that links to supplemental files, and you should find it there.
Yeah. So then we have a question here about how to highlight the 3D feature the way that feature.layer.select features is highlighted in the ArcGIS JS API 3.x. You want to answer that, Miriam, or should I take it?
Of course. No, I hope that it was clear in the presentation. I think the answer came in a bit before I covered that, that you can just use this layer view.highlight on the response from a query.
Yeah. Exactly, and then you get a handle back that you can call remove on to get rid of it, and then the highlight gets removed. Yeah, we can share also some samples. I'm sure we have some samples that we can share. So we will do that afterwards. What is the source of the 3D from? Like by manually drawing or generating import data like LiDAR? So this comes from a colleague of ours. Managed to get this from some open data website. We're gonna try to figure out what the actual get some links for you for this.
Yeah, I'll post a link. Yeah, I'll post a link to it in your answer.
Okay.
I don't know exactly how they generated the data, but I can link you to source.
I'm just checking here.
Assuming you're talking about the Helsinki scene that I did my demo on.
Yep. And so I just managed to we just have some information here now that it's apparently coming from 42,000 aerial photographs and then converted into models. So yeah, but we'll share some more links. What else do we have here? Does the elevation profile tool work with point clouds? That's an interesting one. So at the moment, not really. We did look into it, but we ran into some problems. So for now, it is not. It's definitely a possibility that will become compatible in the future, but at the moment, it is not compatible with point clouds. It is compatible with integrated meshes. It is compatible with normal elevation. Any other graphics you might have in your view, but not point clouds at the moment. All right, we have some new questions coming in. Is there a way to turn off feature thinning? I know it's a performance enhancement, but for specific camera viewpoints, I need it off. Not sure. Would you be able to answer that, Miriam, or? Oh, good. Okay.
Yep. Sorry. I'm not sure. I'd have to check.
Yeah. Well, let's get back to you on that. Maybe we can also discuss this in the Ask Our Experts area through chat. Would probably be easier. Yeah, we would need a bit more details about this. What else do we have here? How can I display measurement results or other UI elements on top of the scene view? So one way is you could build a custom widget. That would probably be the easiest way. So you'd build a custom widget. We can share. There are some samples about this and some documentation on this, on how to build custom widgets. And you can then do like view.ui.add, and you can add your widget to the scene view, and it will be placed in. You can select one of the corners to place it, and it will just show up there. And then you can render the measurement results in there if you'd like. That would be one way.
By the way, just to note that this chat will be like where you type your questions. It's going to still be available. We're going to try to follow up on everything if we don't get through with answering. And you can always drop by on the main page. At the top, there's this Ask Our Experts area. And you can always drop by there in the web channel, I think it's called. Let me check. Web development channel at the very bottom.
Yeah, we have all of our developers there trying to answer all the questions. So I think we've run out of questions now. If anybody, I don't know if anybody has anything else. Otherwise, we will probably wrap it up. Yep. Okay. Yeah. So make sure also to just check some of the other talks that were given by Raluca, by Sasha, about like doing some visualizations in 3D. Also check the road ahead by Javi that has some interesting things that are gonna come in the future or in the near future. And yeah, hit us up if you have any like things that you're missing in the API and the 3D side. We would love to hear from you. Thank you for answering my last question. Let me just, okay. Thank you for answering my last question. I also wonder, is there any recommended sources for us to use for the 3D data sources from Annie? Miriam, have any ideas for like data sources?
Yeah, I'm stumped there. I'd have to check with the team, and I'll definitely get back to you.
Mm-hmm. Yeah, there are many ways to add data, like, and you can get it from ArcGIS Pro. You can get it from like, there are some existing like open data websites where you could get data from. We also have, if you open the scene viewer, for example, you can get some stuff from ArcGIS. So we have a bunch of demo data sets and things like that you could use. Yeah, so yeah, you can search for like the Living Atlas, which is going to be, that's what we call it, like our library of things that you can use. So yeah, that would be a great way to get started. All right. Nothing else incoming. Try to figure out what the results of the polls were, if there's anything interesting that we could talk about. Yeah. Can see that not a lot of people have used the slice tool yet, or the slice widget, or the line of sight compared to the other measurement tools. But it is
it is interesting. There are quite a few things that can be done with the slice.